Hello and welcome to Module 10 of the Core Python Programming course by Mission AI. This is our 10th and final module, so big pat on the back to you for sticking with it thus far. Now, in Module 10, I'm going to cover file IO, right? And this is like a typically hairy part of like any learning any programming language, but don't worry, we're going to make it really simple. We're going to do just the basics. We're not going to do like advanced file IO because a lot of that gets covered in the next course, an advanced Python for data. And there are libraries like pandas that make file IO a lot easier, right? And typically what we want is to either read in data sets from files or write out data sets to files, right? And uh, libraries like pandas make it very, very easy. But in this particular case, we're going to be using the core Python libraries for file IO. So let's just look at the basic operations now. And so the typical flow that we do, right, is you open a file, you do some processing with it, and then you close the file, right? And this is like typically the three-stage operation anytime you deal with files. There's a file opening, then there's the processing, which is either reading or writing, and then maybe additional processing in your program, followed by the file closing. Okay. Now, Python provides very convenient functions for all these three steps, right? Now, let's look at the first step, which is opening a file. So when you open a file, like typically what do you want to tell the Python interpreter, right? First, you want to tell the interpreter what is the name of the file, where is it located, what do we intend on doing with it, and how is the data represented or stored, right? These are like four things you typically want to tell the Python interpreter. So the first thing is where is it located? That is the file name plus path, right? Then what do we intend on doing with it? Like, do we want to just read from it? Do we want to overwrite the entire contents? Do we want to just append to the end of the file? These are the three options we have, right? In terms of specifying our intent. And finally, we need to tell Python how the data is represented and encoded. Sorry. So encoding is nothing but just the way this file is stored internally, right? And there are many different encodings. Like Windows has its own default encodings, Linux has its own default encodings. But my suggestion is always use UTF-8 when you're dealing with text data. Okay, like there's no substitute for that, and like be explicit and specify UTF-8 unless you need something specific like ANSI or ASCII or so on. So explore this table, right, where I can specify the mode in which I want to operate on the file and what the meaning of that is. So if I say mode equals R, right, in my open statement, then it means I'm opening it in read-only mode. If I say it's mode equals W, it means I'm opening it in write mode, right? And that means a couple of things. One is if the file does not exist, Python creates the file for us. And if the file does exist, we're going to overwrite the entire contents of the file. Okay. So opening a file in write mode means you're removing out whatever was there in the past and you're creating new content in the file from scratch. A is append mode, which basically means I'm appending to the end of the file. That is, what was there earlier will be preserved, and I'm just adding new content to the file. And append also creates this file if it does not exist. Now, plus means reading and writing. Okay, so you can perform both read and write operations on the file. Now, this is one part of the mode, right? These first four inputs, that is specifying your intent. Now, the other part is like specifying how exactly you intend, like, do you want to read strings or do you want to read bytes, right? So T means text mode, which means I'm reading strings when I read from the file. B is binary mode, which means I'm reading bytes whenever I read from the file. Okay, so in case of like text files, CSV files, JSON files, we use text mode, right? Because we're getting a bunch of strings and then we're parsing those strings and storing data in either like lines or fields or dictionary objects, whatever the case might be. But then there are other files like PDF, JPEG, EXE files where the contents of the file are in some unreadable format, right? Like it's a string of bytes. And so we read those files in binary mode. Now, for example, if you were going to read the contents of an image and run some algorithms on that, then you'd have to read those images as a string of bytes, as a stream of bytes. Okay, so you'd read those in binary mode. So you would say mode equals RB. So R is for read and B is for binary mode. Okay, so typically the mode is one of these followed by one of these. Okay, now T is default, right? So you don't need to specify T explicitly, but B is something that you have to specify if you want to read in binary mode. Now the encoding is basically the representation or the underlying storage of the file, right? So just make sure you never rely on default encodings, because some file might be generated in one Windows system, it'll go to another Windows system, from there it'll go to Linux, from there it'll go to some server, and this will cause problems. Your file won't behave uniformly like your code. So to make it behave uniformly, use like UTF-8 as the explicit value of the encoding input when you open the file. So I'll show you some code examples of how we open a file. Okay. Now, if we do not specify mode and encoding, then by default, the mode is read, right? That's R, and T, which is text mode. So when I read from the file, I'm reading strings, not bytes. So I'll say F equal to open, and then I just pass the file name, right? So if I pass only a file name, then Python searches for this file in the current working directory, right? And we saw how to get current working directory using the OS module, right? So import the OS module and then do os.getcwd to get the current working directory. Now we can also open the file using the entire path, right? The full path of the file. So this entire directory structure followed by the file name. Now, what Python returns when I use the open function is it returns something that you would call a file handle. Typically, you'd use this file handle term a lot when you like code in C and so on, right? So file handle is basically like it's like a pointer to the file, right? So it knows exactly which point of the file it is at right now. So if I have already read the first 10 characters, it knows that currently the file handle points to the 11th character of the file. So f is nothing but a file handle, okay? And if I type f, I get something like text IO wrapper or something, which is the basic data type that contains the file handle. Now, I have not specified mode, I have not specified encoding over here, right? It's taken default values. Now, let me be explicit about it. I'll say mode equal to R. I don't need to specify T because T is taken for granted. The only time I'd need to specify something in addition to R is if it were binary mode, then I'd have to specify B, okay? And I specify the encoding, which is UTF-8. So I've now opened the file, stored this file handle object in the variable f, and I've specified three things. One is the entire path of the file. I've specified the mode, that is my intention of opening this file, and I've specified the encoding, which is the default way that the contents of the file are represented or stored. Okay, so this is how you open a file using the open function. And remember, open, you have to specify three inputs. Okay, and it's best practice to always specify these inputs. Similarly, whenever you open a file, you're assigning some resources to this, right? Like some memory resources and so on. And when you're done using the file, you have to free up those resources. And how you do that is using the close method on this file handle. So I use the open function, right, to create this file handle f. I then call the close method on this object f to close the file handle and free up those system resources. So let me just look at my, so I have my Mission AI courses live folder, right? So this is where my module 10 code is, which I'm running here. So this is my current working directory. Now, to confirm that, what I can do is I can say import OS and print os.get cwd. Okay, and it shows that it's actually somewhere else. Okay, so let me just change that and say uh, os.change directory. I want to change it to my current working directory, and the reason it's different is because I had I had recorded module 9 just before this, where we had looked at the OS module and we played around with it and we changed these values, right? And remember, I always have to pass uh, double backslash here while specifying the path for Windows, right? And this is like string escaping, right? So double backslash corresponds to one eventual backslash. Okay, so I'll run this and then I'll print out what the current working directory is again. So now we have the current working directory, which is where our code is located. Okay. And this is also where these files are located, right? This input text 1 and input text 2. So those are the files that I want to access. Okay. So now that I've run this code, let me just comment it out. And remember one thing, okay, if you use relative paths, right? Uh, and if you run the code multiple times, then you could get unexpected results. So make sure you specify uh, the full path every single time, okay, as often as possible. So let's run the code that we've written now. I'm in my current working directory. Let me comment out the second line of code. So I'm just going to say open this particular file name. I'm assuming the file name is in the current working directory. I'm going to print the type of the file. And then let me just say I'm going to close the file so that the resources that were tied up to the file handle are now freed up. Okay. So I run this and you can see that what gets printed is class io.textWrapper. So it's basically in the IO module, right, of Python, which is a built-in module. So we've opened this file with just the file name. We've not specified the mode in which we want to open it. We've not specified the encoding. We've not specified the full file path, but Python is smart enough to understand what we mean. Okay. Now let me use the full file path to open the file, right? So this line, so C users, Mission AI courses live, so on, and the file name, okay? And then I print the type of the file and then I close the file. So remember, open is a built-in function that creates the object f, and then I call the close method on the f object to free up resources. If I run it now, I get the same output. It runs successfully. So you can see that open can take either the just the file name and it looks for it in the current working directory, or it takes the entire file path and it opens it up just fine. Okay, so we've seen how to open it, we've seen how to close it. Now let's specify let's add to this statement, right? So at this particular point I've just specified where is this file located. I've not specified what I intend on doing with it, right? Now I'm obviously opening the file in read mode, so I'm going to say mode equal to R. I could have added a T here to say that it's in text mode and not binary, and that's what Python would understand, right? So T is taken by default, so I just don't need to. It's kind of a duplicate here, right? It's implied already. So mode equals R and encoding equals UTF hyphen 8. So I've specified the second and the third inputs also, and let me run the same code here. And I get the same output. Okay, it's just that by specifying more inputs, you're kind of de-risking and you're being more explicit, and you're reducing the chances of getting unexpected behavior. So we've run all this code. We've seen how to open a file. We've seen what the type of the file handle is. We've opened it using both just the file name with the file in current working directory and the entire path of the file. We also specified the second and third inputs, which are mode and encoding. Okay, and finally we close the file. So let's do an exercise now. Open this file, module 10 input text1.txt, which is this one, right? It's in the current working directory. Let's say with and without the full path in read mode with UTF-8 encoding, right? So let me just run that operation first. So I'm saying f is the variable which will contain the file handle equal to open, that is the open built-in function to open a file. Now, first I'm going to say uh, with only file name, and then I'm going to say with full path, right? So f equal open. Now this is the name of the file, right? And I've already confirmed that it's there in my current working directory. So this is the first input, which is the file name slash path. What is the second input? The mode in which I'm operating. And I'm saying read mode, right? So R. And text, so RT is default because it's text mode, not binary. Encoding equal to UTF-8. Okay, so I'm opening the file with these inputs. I'm printing, say, some random message, open successfully, and then I'm closing the file, right? So if I run this now, I get opened successfully, right? And this was just using relative path. So if I use the full path, then I would just copy it from this exercise here, right? I would append the full directory path and then the file name right at the end. And I'm using double slashes here. And I also have mode and encoding, right? So in the first case, sorry, let me just add it here, right, with full path. Cool. So I've got the full path followed by the file name, and the other inputs are the same, right? Mode and encoding, those are the same. So if I run it here, I get the exact same output as before, right? So I've also printed this statement file opened successfully after opening the file, and I've closed the file in both cases. So that part of the exercise is done. And now print the statement file closed successfully after closing the file, right? I'm going to do the same thing at the bottom here as well. Cool. So if I run it, I get the same output. File opened successfully. Oh, sorry. I have to say file closed successfully here. So I opened and closed the first one successfully using just the file name, and opened and closed the second one successfully using the entire file path. And I have specified read mode with encoding UTF-8. Okay. So you now know how to open and close a file by explicitly using the open function and then explicitly closing the file by using the close method. Okay. Now let's figure out this new thing called a context manager, right? Rather than you opening a file, doing some processing, and then forgetting to close the file, what we can do is we can eliminate the need to even close the file explicitly. Excuse me. So if I use the with keyword, that's basically the context manager, right? What I'm saying is I'm creating a new context, right? And the contents of this file are accessible in this context, right? So this block here, this code block, can access, like it can perform operations on the file, which has the handle f. Okay. So I can say f.read, f.readlines, f.write, whatever. Like all the read and write operations can happen within this block here. And the moment I exit this block and go back to the normal level of indentation, f.close is implicitly performed. Okay, so I'm doing f.open at the beginning of this block. Then I'm executing what's in this block, let's say a bunch of operations. And at the end of this block, f.close is implicitly performed. So I don't need to explicitly do it. So with is basically the context manager. You can access the contents of the file and the file object itself inside the with block. Okay. So if I run this code, what do you think happens? So it opens this context manager. Within the context manager, it runs a print statement, and then it exits the context manager and it executes whatever code is outside. Okay. So you get what's inside and then you get what's outside. Okay. And it might not look like a big deal right now because we're still only looking at opening and closing of files. The real power comes when you combine this with reading and writing of files. Okay, so that's what we look at in the next section. First, I want you to get comfortable with just read with opening and closing files. Now, in the previous in this particular case, I opened a single file, right? I used the open function. I passed these three inputs and I stored this file handle in the variable f. And there was only one file. But in the context manager, I can open multiple files at the same time. For example, over here, I've opened this file as f1 and this file as f2, right? And I've printed something over here. And I've also exited and printed another print statement. So if I run this part, sorry, it'll run successfully with no issues. In the previous case, I opened only one file using the context manager. In this case, I'm opening this file and storing it in f1, then comma, this opening this file and storing it as f2, right? Now, you might be asking, why on earth would I be doing something like this? Now, there are cases where I want to open up two files where I read from one file simultaneously as writing to the second file. So I read from one file and the same contents I write to the other file, right? So I'm creating a copy of that file. Or I can read from one file, do some processing on the inputs, and then write the output to the other file. So I have both these files open simultaneously, and at the end of the with block, both these files are closed simultaneously. So if I run this, I get this statement inside the with block and then the statement outside the with block. Okay, so you've seen I'm just giving you these features right now. We're stacking up these features and then we'll see how to really unleash the power of these features when we start reading and writing from and to files. Okay. So remember, with is the context manager. It eliminates the need to close the file explicitly. We use the open function for file f1, open function for file f2, and then we can access both f1 and f2 inside the with block. I mean, the file object itself, f1, would still be like, I could still print type of f1 outside, right? Like over here, I can say print type of f1 and it'll give me this answer, right? Because the f1 object still exists, but I cannot do an operation like read or write because the file object is now closed. So if I say print f1 dot read line, okay, I'll explain what readline is later, but it'll throw an error because I'm trying to perform an IO operation on a closed file. Okay, so the F1 object still exists outside, but it's a file handle of a file that is already closed. Cool. So let's do some exercises using the context manager, right? Use with to open this file in read mode with UTF-8 encoding. Print file opened successfully after opening the file. Print file closed successfully after exiting the context manager. So I'll say with open of this file, right? And that is the first input to the open function. The second input is mode, which is R, right? The third input is encoding, which is UTF-8. And in this case, I've specified only the file name because the file is in the current working directory. And I need to say, use it as the object f, right? So instead of saying outside over here on top, I had said f equal to open and then f dot close. Here I'm saying with open as f. Okay, notice the difference between those two. So I'm going to say print statement here and print statement outside. And inside, this is the message, and outside, this is the message. Okay, so there is some invalid syntax here. Okay, so it says file opened and file closed successfully. So I've used the context manager successfully, right? So using with, I have opened this file, and the output of that open uh, function is saved in the variable f, that is the file handle. In this with block, I have access to perform all the operations on f, and then outside this with block, I cannot perform any operations on f. Okay, but f still exists. Now, let's simultaneously open both these files using only one with statement, right? So I can just, it's similar to the previous exercise. So I'll just copy this code, and now I'll add a second uh, open statement here, right? Open this particular file, text input text2.txt in read mode with the same encoding as f2. Okay, and now I'll say print file open successfully and print file close successfully. So it's run it successfully. Okay, so I've used context manager to open one file. I've used context manager to open two files simultaneously. Okay, and both files have been closed implicitly without me needing to explicitly state it. Now, the final aspect here is for any operation that you do, whether it's open, read, write, or close, right? Any of these operations, if the operation is unsuccessful, Python will throw an IO error. Okay, so whenever you're doing any IO operation, always include the code in a try block and always handle the IO error exception. Okay, now in this particular case, I won't get an exception because this input exists in the current working directory, right? So what will get processed is this print function here and this print function here. Okay, so if I run that, that's what I get, right? But what happens if I specify the wrong file name? Let me add the number one here. So now the file name does not exist in current working directory, and it throws an IO error which gets caught over here, and the print message gets printed. An IO error exception was caught. If I change it back to a recognizable file name, it runs successfully. Okay, so make it a point to always handle IO errors whenever you're doing any file IO operations. So open both these files using only one with statement, right? Print the statement file opened successfully. Let me just write this out so that it becomes like we're getting the repetition in, right? So with open this file in read mode with UTF-8 encoding as F1, and then using the same thing with the same mode and the same encoding, and I'm storing that particular output as F2, right? Now I'm going to print a statement here inside the with block. I'm going to print a statement here outside the with block, and let me just add those print statements first. Okay, I'm going to add that here. Now what am I doing? I'm catching and handling any IO error exception that might get generated in the process. Now, what is the IO operation I'm performing? Open over here and open over here, right? So these could potentially throw the IO error exception. So I need to handle that by including this in a try block. And the whole thing, I'll just select the entire code and press tab once, so it gets indented with one tab space. Okay, and then I have the except block that handles the IO error exception, right? And I can say print IO error exception. Okay, so if I run this here, sorry, there's an invalid, God, I keep making this mistake with print. Okay, so it says caught the IO error exception, which means there was some problem here, right? And the reason is because I had not specified the extension of this file, which is a .txt file. So if I run it now, it says these statements were run successfully, right? And in the previous case, when the file name was not correct, you saw that it threw the IO error exception, which was then caught and handled. Similarly, if I just change this first file name to something that does not exist, it catches the IO error exception. Okay. And now if the file name does exist, it runs successfully. So we've seen how to use the with context manager to open files and perform operations on them and automatically close the files. We've seen that all these IO operations throw an IO error if they're unsuccessful. So we include all these operations in a try and except block. And so that brings us to the end of the section on opening and closing files, right? So now we have to get to the real chunk of it, which is reading and writing from files, because there's no point just opening and closing. You can't do anything with that, right? But reading and writing is where the actual fun is. So I've already told you that uh, when I open a file in read mode, I'm saying mode equal to R. And there are two possibilities, right? One is text mode and one is binary mode. So text means it reads strings. Binary mode means it reads bytes. Okay. In this particular case, we're just going to be using text mode. Okay. So now there are three main functions to read from the file, right? The first is read of n, where n is the number of characters, right? So it reads the first n characters and returns them, right? And it also moves the file pointer from, so remember, when you open the file in read mode, the file handle contains a pointer to the beginning of the file. Okay. Now, the moment you say file.read, let's say 10, it reads the first 10 characters, and now the file handle points to the 11th character of the opened file. Okay. And if we do not specify n, it reads the entire file at once. Okay, so that's the read function. Now another function is read line. Okay, so read line basically reads from the current file pointer position till the first new line character that it encounters. Okay, which is basically backslash n, and it includes the new line character. So if I say read of 5 and I do these operations successively, first it reads the first 5 characters. Then if I say read line, it'll read from the 6th character till the end of the line where it encounters a new line and it includes that new line. Then if I say read lines after that, so now the file pointer is basically at the beginning of the second line. So read lines will then take the entire input of the file and split it up into lines using the new line, that is the backslash n character, and it will convert that into a list of lines. Okay. Remember, the position of that file pointer is most important. So when you open the file pointer in read mode, the file pointer points to the beginning of the file. So after the read function where you specify n, it points to like one character after n. Okay. If you say read line, it will read from that particular pointer position till the first backslash n is encountered, and then points to the next character after that. And read lines will then read from the current pointer position right till the end and split up that entire blob of text into multiple lines, okay, and put that into a list. So I would say using the with context manager, open the file, right, in read mode with this encoding, okay, and I'm storing that in the variable f. So I'll say f.read 4. So it reads the first 4 characters. Then I'll say f dot read line. So it reads the entire first line minus the first 4 characters. So whatever is remaining basically after this first read operation. Then it does another read line. So it prints the second line. Then it does read lines. Basically, from the start of the third line onwards, it reads the entire thing as one chunk of text and then splits it up into multiple parts wherever it encounters a new line character, and it stores those multiple parts in a list. Okay, so if I run this over here, so what am I getting, right? So first let me show you what is the content of this file. I just have 5 lines, right? Each of them separated. At the end of the first 4 lines, there is a new line character. At the end of the fifth line is the end of file. Okay. So if I go back here, what I'm saying is f dot read, right? Which gives me these 4 characters, right? Which is what I get over here. Now, the next thing I do is f dot read line, right? So the file pointer is now pointing to this character over here. It's here. So f dot read line will read from here till the first backslash n, that is the new line character, is encountered and including it. So it reads this entire thing and returns it. And here I print it out, right? Now remember one thing. I'm printing out this entire thing including backslash n, okay? And print's default ending is backslash n, which is the new line character. So which is why there are 2 backslash n's, and which is why this line is empty, okay? This middle line over here. Now what happens next? It has come to the end of line 1. It has read that entire thing, and the pointer is now at the beginning of line 2, okay? What is the next statement I'm making? The next statement I'm making is again f dot read line. Okay, so oh God. So it goes from here all the way to the end, including the new line character. It returns that and moves the pointer to the beginning of the third line. Okay, and when I print it out, I'm printing the end as just an empty string rather than a default backslash n. So this is line 2, and after that there's no empty line because I've specified the ending over here in the print argument. Okay. Now where are we? We're at the beginning of line 3, right? And I say f dot read lines. So it reads this entire bunch of text in, and then splits it up based on the new line character. And those individual lines are contained in a string. So first we have, this is line 1, which is the first element of the string. This is line 4, which is the next element of the string. This is line 5, which is the last element of the string. Okay, so that's how this read, read line, and read lines functions work. You can see the string over here. And you can see that the backslash n character is contained in each of these lines, right? In third and fourth, but not in the fifth. Cool. So this is how reading in text mode works. Okay. Now, if I were to do the exact same operations, but the mode is reading in binary mode, let's see what I get. So I would get the raw string. Okay. As of now, I get the string in text mode, but if I read in binary mode, I would get the raw string. Okay. And the string representation here in the output would also be different. So just remember what this output looks like. And now see the new output we're going to get. Okay. If I run this, you can see firstly, there's a B before the string saying that it's binary uh, bytes that have been read. So this is the first string, right? Is line number 1, and it shows you the backslash r backslash n, which is the carriage return as well as the line feed character. After the second read line, it gives you the entire second line followed by backslash r backslash n. Okay, and then it gives you the list of lines, right, using the read lines function. And here again, there's backslash r backslash n at the end of the third and the fourth lines, and nothing at the end of the fifth line. So you're basically getting the raw string in binary format if you use binary mode. Otherwise, you're just getting the string in text mode with normal text followed by the \n character. Okay, so we've seen how to use these three main functions for reading from a file. Okay, uh, now another thing we can do is we can we can process the contents of the file as it is being read, right? So we open the file using the context manager, and then we process the contents of the file, right? So now there are two ways of processing it. One is you go line by line. So you say for line in f, right? Which is basically saying f dot readline, right? So each time you're performing f dot readline, and you're doing that till the end of the file is reached. Okay, so this is one way of doing it, where you're going line by line. So you're saying for line in f, print line, okay, with this end character. Another way of doing it is to read the entire contents of the file into a variable, which in this case happens with the f.readlines function. And then you say, I'm going to iterate over that, right? For line in f.readline. So basically you have a list of lines, and now you're printing out each line. But the processing has already happened over here. Like you have the entire thing stored in memory already. Here you're getting each line into memory one by one. So the pointer initially is at the beginning of the file, right? Then you're performing an f.readline operation, and you're going to the beginning of the second line and printing out the first line. Then in the next iteration of the for loop, you're reading out the second line, pushing the pointer to the beginning of the third line, and then printing out the second line. So you're going line by line by line using this particular method. And if you use f.readlines, then you're processing the entire contents of the file at once. In the first case, I've opened the context manager, and I processed the file line by line. In the second case, I've processed the entire file at once by using f.readlines, and then I'm iterating through that processed output. Okay, so let's run the code above and see what we get. The output is the exact same, okay, but the way of processing it is different. Now, if you have a humongous file, the second method is going to be a lot more memory intensive than the first method. So if I run this, I get this output here, right? And if I run this, I'm again printing line by line, and I get the exact same output. So both these bits of code give me the same output, but in one case, I'm iterating through the file line by line. In the other case, I'm going through the entire file once and then iterating through that output. So let me do an exercise here. Now, using Context Manager, open the file module 10 input text 2 in read text mode with UTF-8 encoding. Okay, so I say with open of this file, right? In mode is equal to read, encoding equals UTF-8. Now, what am I doing in here, right? So I'm opening it and I'm assigning it to the variable f. Print the first 6 characters of the first line. So I'm going to say print the first 6 characters. So f dot read 6, right? And I'm printing the first 6 characters. And what am I doing next? I'm printing the remainder of the first line. So print f dot read line, right? So right now, after the first operation, the pointer is at the 7th character of the first line, and it reads from there till the end, including \n, right? So I'll say f dot read line, and I'll specify end as end equal to empty string, just so that I don't get a empty line between the second line of output and the third line. So now I'm going to print out the second line using f dot read line. And again, here there is a \n already, so I'll just say end equal to empty string. Now I want to print a list containing the remaining lines from the third line onwards. So I'm going to say print f dot read lines, right, which gives me a list of individual lines from the third line onwards till the end. And third line onwards because first and second have already been read over here. Okay. And it says for each change the default line ending character to space. So I'm going to say instead of empty strings, it's space. Okay. End equal to space. Cool. So if I run this now, I get the first 6 characters on the first line, and then the print statement by default has the ending of new line. So it goes to the next line. Now, on the second line here, it prints the entire remaining second line of this file, right? Entire remaining first line of this file, which is the last part of the, which is E, and then all this other stuff over here. Okay. This statement prints out the next line of the file, which is line 2. That's here, right? And if you look at the actual file, this is exactly what we see. This is the entire first line. This justice till political is the second line, which is here. And then you have a list of lines which are from third onwards right to the end. Okay. So we've seen how to open it using the context manager, assign it to the variable f, that is the result of the open function. And the open function has 3 inputs. And inside this with block, inside the context manager, we're reading using the read function, the readline function, and the readlines function, or rather the method on that file handle object. And each time the file pointer updates its position. Now print out each line of the file using a for loop, both with and without readlines. So I'm going to open the file, let's say with open as f, right? So I'm going to iterate through the lines with and without readlines. So I'll say for line in f, print line with end equal to just empty string. So this is the first method of doing it, right? I'll say method 1. And the second method is with open of the same file, right, as f. Now the loop will be for line in f dot read lines print line. The difference being that here I'm actually going line by line in the file and I'm reading into memory one line at a time. Here I'm reading the entire bunch of lines into memory in the form of a list, and I'm going through that list and printing out values. So the output in both cases is the same, right? So I just need to add end equal to this over here. So the output in both cases is the same, but the way I achieve it is different. The first one is more memory efficient, but might be a little slower. The second one takes up more memory because it's reading the entire thing at once, but it could be faster. Okay. So we've seen how to read from a file, and we've seen the 3 main functions to read from a file, right? And we've also seen how to read the entire contents into memory at once, and we've seen how to go line by line. Now we're going to get to the part of writing to a file. Okay. So in the previous case, when I opened the file, I said mode was R, which is read, right? So now I have 2 ways of writing to a file. One is in write mode and the other one is in append mode, right? So write mode basically means it's going to overwrite the contents of the file. That is, whatever existed earlier will be wiped out, and the file pointer is at position 1 and it starts writing from scratch. Okay, and if the file name does not exist, it'll create it. Now append means the file pointer points to the end of the file, and whatever I'm writing comes after what was already there. Okay, so I do not erase what was there, I just add to it. That is, I append to the end of it. And again, here also, if the file does not exist, it gets created. Okay, and just like in the previous case, the default is text mode, which is the T option in mode. And if by chance I were writing to a binary file, then I would use the B option along with W or A. Okay, so I would either say WB or AB. Now I can use two functions or two methods to write to this file object. Okay, so one is write, where I write a string, and the second one is writelines, right, where I write an entire list of lines. Now, here's the important thing to remember. It just writes something, and then the file pointer points to the next character, okay? The next position where it can take more content. It does not write a new line character on its own. If you want to write a new line character, you have to write that on your own, okay? So let's say I open this file in write mode, okay, specifying W. I don't need to specify the name of the argument explicitly saying it's mode. I can also just specify W and it knows that the second argument is mode. Okay. So I have that file handle in the variable f. So I say for I in range 1 to 11, that is the numbers 1 to 10, f dot write string of I. That is, it converts this number, the numbers 1 to 10, each of them it converts to a string. It adds the new line character and writes it to the file. So so the file pointer was at the beginning of the file, then it goes to the end of the first line, and after the backslash n, beginning of the second line. Okay, so it writes the numbers 1 to 10 with each one number on each line. That's what this particular operation does, and I can print it out using this for loop inside. So let me run this first part of the code and show it to you. So just remember, I'm opening the file in write mode. Okay, before all this while I was opening it in read mode, and there were times I didn't specify any mode, and in which case the default is read. Okay, and here I am printing it out. The name of my file is first written file.txt. So if I run this, I get this output here, right? I'm printing out this output from the file, first written file. And if I go back to my folder here, I have this first written file.txt. And if I open it, I have the values that I wanted. Okay, so this is how you write to a file. Just remember, just like you have a f.read, you have an f.write. Okay, now the write does not magically think, oh, I'm going to write a new line character and be very smart. No, it doesn't. You have to specify the new line character if you want. So this is the first operation, right, where you're just writing content to a file and you're printing out the contents of that file. And you're overwriting, like for example, now I created this file from scratch, right? This first written file.txt. It did not exist earlier. In this folder, this file was not there, but now it is there, which means that if the file that is passed to the open function in write mode does not exist, then the file gets created. Okay. Now the next thing I'm going to do is I'm going to append to this file. So it's still the first written file.txt, right? But now the file does exist. So I'm going to append to it, okay? And append means it returns a pointer to the end of the file, and whatever I do f.write over here, it gets added on to what was already written over here. Nothing gets erased, okay? So now I'll write out the numbers 11 to 20 using the same f.write method in this loop, okay, with this same file as above being open. And then I'm going to print out the contents of the entire file. So let me run that over here. So now you can see that when I print out the contents of the file, I see 1 to 20, right? And if I go back here and I open first written file, you can see it contains values from 1 to 20. So initially I had written 1 to 10 in write mode, and then I wrote 11 to 20 in append mode. Okay, cool. Now let me show you what happens to an existing file if I open it in write mode. Okay, so now first written file, I had already created it here and written the first 10 numbers to it. Then I appended 11 to 20 to it, and now I have the file in that state, right? Now I'm going to open the same file in write mode, which basically means it erases the entire contents and now writes new content to it, okay, from the beginning. So now the file should only contain the numbers 21 to 30. So if I overwrite the contents of the file by opening it in write mode, and then I print out the contents of the file over here, I should get only the numbers 21 to 30, which is exactly what I get, right? And if I open this file again, you can see that it contains these contents, 21 to 30. Okay, so I've shown you how to read from a file using three functions: read function, read line, and read lines. And I've shown you how to write to a file. I've only covered the first function here, which is write of string. So f dot write. Okay. Now we can also, uh, like for example, if I had, how would I use the f dot write lines function, right? So if I'm saying I'm writing a bunch of lines, I need to basically pass a list of lines to it, right? And that we'll cover over here. And I had also told you that the context manager becomes even more powerful when I open two files and I'm reading from one and processing the output and writing to a second file simultaneously. So if I were to open, uh, let's say, the contents of this first input text one file, right? I'm going to write that to second written file in write mode. So I'm basically creating this file and writing from the beginning. Okay. So let me just run that code over here. Remember, so I'm taking the contents of this file and I'm putting it in a new file called second written file. Now, let me just close this. So the file that I'm reading from is this one, containing these 5 lines. Okay. And for each line in the input file, I'm writing to the output file. So there is this open function that returns the input file, comma, there is the open function that returns the output file. So I'm saying iterating through the input file, that's fin, I'm writing to the output file using the write function, that is fout, okay? And then I'm printing out the contents of this file. So the same file that I just created here in write mode, I'm going to open it in read mode and print out its entire contents, and it should be a reflection of what is there in this file. If I run that, I get the exact same content here, right? And I need to probably not add the \n over here because it's already there. There is a \n at the end of each line. So if I run it now, I get this compact, this is line 1, this is line 2, and so on till this is line 5. So in a sense, I've read line by line from the input file and I've written that same line to the output file. Okay, and at the end of this with block, both files are closed simultaneously. Now I'm opening the second file in read mode and I'm printing out the entire contents. So if I go here and I now see second written file, right, which gets created. And if I open it, I see these lines over here. Okay. Now let's see how we can achieve a similar thing using write lines. So how would I get a list of lines from, let's say, the second input text 2 file, right? I will get a list of lines using fin dot readlines. So for the input file handle, I call the readlines function and it gives me a list of all the lines, right? And all I'm doing is writing that list of lines to the output file using the writelines method. So I'm writing the lines that I have read into a list using readlines. And let's say I'm doing this in append mode on the same second written file. Okay. So second written file had these contents, right? This 1, 2, 3, 4, 5 from this input text 1 file. Now I'm going to append the contents of input text 2 using f.readlines. So let me copy that here and replace this code with this, right? So I'm reading from module input text 2. I'm opening the same file in append mode and I'm writing all these lines one by one. Okay. And then I'm again going to print out the contents of the second written file. So now you can see that I had these 5 original lines, right? And then it's appended to that. All the contents of the second input text2 file, it's added to the end of this. So I've shown you how to read from one file and write to another file simultaneously using going line by line using f.write. And I've also shown you how to dump out the entire output in one shot using writelines and by supplying a list of lines using the readlines function. Cool. So let's do an exercise here or two. Write the first 10 negative integers into a text file called file writing exercise 1. So let's say uh, first 10 negative integers, right? Now I'm going to open a file first in write mode. This is the name of the file, mode equal to W, and it's text. So T is implied. Encoding equals UTF-8, and I'm calling this file F that I'm opening, right? And I want to write the first 10 negative integers. How do I get the first 10 negative integers? So I'll say for I in range, what am I starting with? -1. What am I ending with? -10. So I want to go all the way till -11 in steps of -1, right? So I'm starting with -1, then I'm adding -1 to it to get -2, and so on. I'm going all the way till -10, right? I'm going to say f dot write. I'm going to say f dot write string representation of I plus the new line character. The new line character is \n. So each, uh, so I then basically get one integer per line, right? So what am I going to do next? To this file, append the individual squares of the first 10 negative integers. Okay. So let me say with open the same file, but this time in append mode. Okay. Mode equal to A, right? Let me call it F again. What am I doing? I'm appending the individual squares of the first 10 negative integers. So I'm going to have the same range, right? It's for I in range -1, -11 in steps of -1. I want to say f dot write string of, this time I'm saying string of I to the power of 2, right? And I'm appending the new line character. So I had the individual negative integers here that I wrote to the file. I now have squares of those first 10 negative integers that I'm appending to this initial list of 10 integers. Okay, so one square per line. And finally, print out the contents of the file. Let me just iterate over each of the lines and print it out. Okay, so with open of this file, but in this case, I'm opening the file in read mode, right? Mode equal to R. And I can just, for best practices, say encoding equals UTF-8. Okay. There are times when people might specify that I'm providing you certain input files in ASCII format or certain input files in ANSI format. Then you have to specify ASCII or ANSI as the encoding. Okay. So whatever the encoding value is, you specify it. Saying as F, what am I doing? For line in f, print line, right? So let's see what we get. In the first go, I'm writing to this file. In the second go, I'm appending to this file, and then I'm printing out the entire thing. So you can see that I get the entire list of negative integers from 1 to 10 over here, and then I get the entire list of squares of those negative integers. And while printing line, I can just say end equal to empty space, and this is what I get. This is the contents of the file. Cool, so we've done our first exercise. Now let's move on to the second one. Create a new file, file writing exercise 2, containing every line from the previous file writing exercise 1.txt, and use the writelines function, and then print out the contents of this new file, right? So let's say with open uh, this particular file, right? This is the first file I'm opening. So open this in read mode. Okay, and this has to be a string as f in, right? This is my input file which I'm reading from, and I'm opening this other file in write mode. And since it does not already exist, Python will create it. Okay, mode equal to w utf8. Okay, and I'm calling that as f underscore out. Okay, now I have my with block inside the context manager. So what am I doing? I'm using writelines. Okay, so I'm reading the entire contents of this file using readlines, and I'm writing it to f out using writelines. So I'll say f underscore out dot writelines, and what am I writing? I need to pass it a list of lines, right? So how do I get the list of lines? I say f underscore in dot readlines. That's it. And now I want to iterate over this particular file. Sorry, this file. And I want to open it in read mode, and I'll call it f. Okay. For line in f, print line with end equal to empty space. So I have the entire contents here that was copied from this file into this file. So what I've done is I use the read lines to read from an input file, and then wrote that to the output file using the writelines function. Okay, so now let's create a new file called file writing exercise 3, containing every second line from the file we just created in exercise 2. Okay, so again, we have an input and an output file. Let me just copy these values so that I make it a little faster. Okay, so I'm going to say with open of file writing exercise 2 in read mode as f underscore in, right? And then file writing exercise 3 is our new file, which we're opening in write mode as f underscore out colon. Now I'm going to write my code to pass every second line, right? So I'll say line underscore num equal to 1. Okay. For line in f underscore in. So for each line in my input file, I'm going to first check if line number is even. Okay, mod 2 equal to 0. If it is even, that is every second line, I'm going to write it out to the output file. So f underscore out dot write the line that I just read, right? And I don't need to write an additional new line character because the lines in the input function already contain a new line character at the end. So if the line is an even number, write it to the output file. And I also need to increment line number, right? line number plus equal to 1. Cool. So now let's iterate over the newly created file, right? Which I'm going to open in read mode with open of this particular file, which is the newly created file over here, right? Here I'd open it in write mode because I was writing to it. Now I'm opening it in read mode because it's already been created as f. I'll say print f dot readlines. Okay, so if I run this now, you can see that it's written every second line to this output, right? So actually, let me print it out a little more descriptively. For line in f, print f dot read line, and then pass the end character as empty space instead of new line. I just need to print line, no, not read line. So I get -2, -4, -6, -8, and 10 from the first set of 10 outputs every second line. Similarly, 4, 16, 36, and so on from the second set of outputs. So I've got every second line from the second file into the third file. Okay. So I just used a for loop and I checked for this condition. And if the condition is true, I write. And I also increment this variable used in the condition. Okay, so we've seen how to read and write from and to files, right? Now we're going to use generator functions to read large files efficiently. I covered generators in module 6, right, along with list comprehensions and so on. And what is a generator, right? It's a Python object that basically employs lazy evaluation. So instead of reading everything from a file into, let's say, a list of lines, right? And if the file was huge, then I would be occupying a lot of memory space with that list, right? So rather than holding the entire contents of that file in memory at once, I would rather use lazy evaluation, right? So instead of saying list.append each new line that I encounter, I will use the yield keyword for generators. So if you haven't already heard of generators, please go to module 6, check them out. It's a very simple concept, okay? But the idea is it's like I'm not storing the value directly, but I'm telling the generator how to retrieve the value. Okay, and it retrieves it really fast. And the generator is basically like an iterator, okay, which basically means I can use the next function and pass the generator to it to get the next value. And it is stateful. So it remembers which is the previous value that it got, and it remembers which is the next value that it's supposed to get, and it also knows how to get that value. So what I'll do is, let's say I define a function, okay, which takes this file object or a file handle as the input, right? And my docstring says I have a generator function to read a large file lazily. So I'm going to create an infinite while loop over here, and I'm going to say file object dot read line. So it reads the first line, for example, returns that first line and pushes the pointer to the beginning of the second line. Okay. Now, if data is basically an empty string, and this is the output that you get if we've reached the end of the file. So when it encounters the end of file character, the read line method basically returns an empty string. Okay. So if we've reached the end of the file, then break. Okay. So that means get out of this infinite loop. Else yield data, which basically means data is actually something, there is still data to be read. Yield data. Instead of appending it to a list, use the yield keyword to tell the generator what the next value should be. Okay. So I have the generator function which basically reads, or it adds each line of this file into the generator. Okay. And now I use a context manager to open this file. I call the generator function to read the large file, and it does so efficiently, right? It's stateful. So as of now, the iterator is pointing to the beginning of the file. So if I say next of gen file, it gives me the first line and points to the beginning of the second line. So if I say next again, it gives me the second line and pushes the pointer to the beginning of the third line. If I say next again, it gives me the third line and pushes the pointer to the beginning of the fourth line. And now I go through a for loop to go through each line in the generator and print it out. So if I run this above code, let's see what we get, right? Cool. So if I run this and I print it out, I basically get this entire thing, right? And let's say I'm reading from this input text2.txt file, right? Which is basically this entire text, this preamble of the Constitution, okay? And in each of these print files, let me say end equal to empty string instead of the default new line character. And here also. So now you can see that I've printed the first three lines one by one by one, and then I've printed the fourth line onwards in a for loop, okay? Now, it won't make any material difference to you when you're for example using a small file like the one that we have. But let's say you have a file with, let's say, a million lines of data, right? In that case, if you want to process each line of data one by one, then it makes sense to use a generator and iterate through it, because otherwise you're going to end up hogging up a lot of memory by storing the contents of that file in a list. Okay, so let's do an exercise here. Write the contents of input text 1 to a file called generator input. Okay, so let's say I with open of this file, and right now let me not specify the encoding input because we already know that it is UTF-8, right? So I'm going to open this in read mode and I'm going to call it f input, right? And I'm going to open this other file, generator input.txt, and I'm going to open that in write mode, right? Because I'm writing to it for the first time and it doesn't currently exist. Mode equals W as f underscore out. Okay. So I have f underscore in and f underscore out. F underscore in is what I'm reading from. F underscore out is what I'm writing to. Okay. So write the contents of this file to this other file. So I'm going to just say f underscore out dot write lines, and the input to that is f underscore in dot read lines, right? So this is a simple way of just copying the output from one to the other. Now I already have this file created after running this statement. So now I want to append the contents of input text 2 to this same file. Okay, so I'm going to copy this code. I'm going to paste it here, right? Now I'm opening input text 2 in read mode. I'm opening generator input not in write mode but in append mode, and I'm appending the contents of input text 2 to what was already there, which was basically the contents of input text 1. Okay, so now I'm going to define a generator function to read an input file lazily and to return a generator object of the file. Call this generator function generator with this particular input, right? So let's say define gen function which takes f, right? I can either pass the file handle or I can pass uh, the path to the file. Let me say f refers to the file handle, right? Read an input file lazily. So what am I going to do? I'm going to say I'm creating an infinite loop, right? I'm going to now say line equal to f dot readline. I'm just reading the line from this file f that I've passed to the uh, generator function, right? And if line is an empty string, we know that we have come to the end of the file, and I'm just going to say break out of the infinite loop, right? Else, I'm just going to say yield line, right? And yield line basically adds this data to the generator, okay? So I keep running till I basically got get all the lines out, and that's about it. So that's what my generator function returns, right? Instead of doing a list.append, the equivalent for a generator is yield line, okay? Now I have my generator function defined, right? So what am I going to do with it? Call this generator function with this particular file as the input. So let's say I open this file, right, with open of generator input.txt as the input. I'm going to open this. This is the file name. I'm opening it in read mode, uh, and I'm going to call it f underscore in, right? So first I'm going to call generator function with f underscore in, and I'm going to call it gen object. So generator object is the output of the generator function where I pass f in as the file, right? File handle. So now I've got my generator object which knows exactly what the lines are and how to calculate them or how to retrieve them from the file, right? And remember, this is lazy loading. So the file still has to be open while I retrieve items from the generator. So now what is it saying? Print the first two lines of the generator and then print the remaining contents of the file by wrapping the generator object in an appropriate function. So what I'll do is I'll say first print next, right? Because it's an iterator. I can call the next function. Next of gen object, right? And I'm going to do the same thing again to print out the second line, right? And let me say end equal to empty string. And finally, I'm going to say print all the remaining lines by wrapping the generator object in an appropriate function. So I'll say for line in list of gen object. So I'm basically converting that entire thing into a list, right? I'll say print line with end equal to empty string. Cool. So I've defined this generator function and I'm using this generator function in this code block, right? So first I'm creating it by passing the input file over here. The generator function then figures out how to read all this data from the file. So I print out the first two lines and then I iterate through the remaining lines. So if I run this now, you can see that I've basically got this entire thing over here, which was my uh, first, my content from this file got added to generator input, right? Which is these 5 lines. Then the contents from this file got added to generator input, which is from here right to the end here. Then we define the generator function, and then we printed out its contents by explicitly using next and then by iterating through the rest. So you can see how useful this generator is, right? Like as of now, it might seem like extra work, but as your file sizes start becoming huge, then generators really help. So that brings us to the end of module 10 and brings us to the end of this course. So we basically understood how to do the entire end-to-end file IO in Python, right? So we open the file, we do some processing, which is either read or write, and we close the file, right? Now, if you want to open the file then you just say f equal to open of three inputs, right? You pass three inputs to the open function: the file name or path, the mode in which you're opening it, which could be read, write, append, and additionally, whether it's binary or not, and also the encoding, which is like the way that the file contents are stored or represented. We typically use UTF-8, and make sure you explicitly specify an encoding. Okay, so when you open a file in this particular way, you also close it explicitly. So you say f.close, right? Another way of managing this file lifecycle is using the context manager, where you use with, right? So you say with open of this particular inputs as file object, and this is basically the file handle, and within, after this colon, whatever comes is a code block for the with context manager. So the contents of the file operations are accessible within this block, and outside of this block, the file object still exists, but it's not open anymore. Okay. So we've seen context manager. We've seen that all file operations can potentially throw an IO error exception. So ideally, I would have wrapped this entire thing in a try block, and in the except block, I would have handled the IO error exception. Okay. We then saw how to read files, and we saw three primary functions to read. That is read, where we specify a number of characters. Then we have read line, which reads from the file pointer to the end of the line, including the new line character. And then you have read lines, which reads from the file pointer to the end of the file and splits up the text into lines based on the \n character, right? Then we saw how to write to a file, and in both write and write lines, there's no \n or anything that's appended. You have to put it explicitly if you want. Okay. And finally, we saw how to use a generator function to read large files efficiently. So thank you so much for sticking till the end of this module. Please do your practice and all the very best. Reach out to me in case you have any doubts.